Hey everybody. Today I want to talk to you about math and money and how building wealth is nothing more than a math formula. So whenever you are trying to build wealth, long-term wealth, the most important formula you need to know is the power of compound interest. So before we talk about compound interest, just want to show you why compound interest is the eighth wonder of the world, which Albert Einstein once famously said, because the blue line is a linear equation. This is just a simple interest formula where you take the amount of money, your principal, and you just multiply it by the interest rate times the time. Your rate of return is constant, whereas the red line is the rate of growth of money invested and being compounded. And this is an exponential function because, as you can see, it's multiplying your amount times your rate of return to the 10th or to the T power, which is the amount of time you have in the investment. And your money is going to grow exponentially. So let me quickly go over what we're going to go over today. First, you're going to learn about how to double your money using the rule of 72, which is basically a shortcut for you to estimate how long it will take your money to double using compound interest. And then I'm going to talk about how starting early can really affect the outcome of your wealth in the long run. And this will blow your mind. And then we'll go over some different scenarios with different interest rates, as well as when to start investing. So, like I said, Albert Einstein once said that compound interest is the eighth wonder of the world. Those who learn it, earn it. And those who don't, pay it. Because compound interest, the math formula by itself, allows you to grow your investment and compound your returns just like a snowball. And let me briefly go over why it's so important.
Welcome to Simply Money. I want to share with you a
So here,
on the left-hand side,
you're going to see a very important.
on the left-hand side, we have this young man named Ben. At 19 years old, he begins putting $167 a month, which is $2,000 annually, into an investment platform, maybe.
All right. So what you see here is a chart of where, if you invest early, let's say you have $2,000 a year and you invest it at 19 and then you stop investing altogether. And this investment is earning a theoretical 10% rate of return per year, which you could average in the S&P 500 or the stock market index. What's key is he only invested for 8 years, and this money, he stopped putting money in and he just let it grow using the power of compound interest. And at the age of 65, he actually ended up with $2.2 million. Whereas if you were to wait 8 years, and we have example number 2, Arthur, who wanted to, let's say, spend all his money in the beginning, buy a new car, and did not invest until he reached age 27. And you can see he caught up at 27,000. This is the amount where Ben stopped investing, right? After 8 years, he had $27,000. So Arthur also has $27,000. But at this time, because of compound investing, Ben has $68,000 at that point because he was able to have his money working for him from 19 to 34. So now at this point, you can see when Arthur grows his money, he actually continues to put in $2,000 every year all the way to 65. And although Ben only started with 2,000 times 8 years, he put in a total of $16,000 and then stopped investing altogether, right? So $16,000 versus Arthur, who put in $2,000 but did it for another 40 years. He put in a total of $80,000. And intuitively, you would think that Arthur would make more money, but because time plays such an important factor, you'll see that by the end of age 65, Ben actually made 2.2 million, whereas Arthur only had 1.5 million, even though he put in 80K and Ben only put in 16K. And this is why the power of compounding and time plays such an important factor. Because as you'll see here, let me delete this. By the time Arthur made $27,000, which is where Ben stopped investing at age 26, his money grew to $68,000. And so he's already ahead by almost 40,000. And what's key is this: at $68,000, it takes Arthur about, I don't know, let's say age 40, right, to make about $68,000. In this case, he made 72. But Ben already accumulated $134,000 through a 10% compound interest. Now let's see, where does Arthur make 134,000? So let's just guesstimate around here. At age 45, he makes about $142,000. But through compound interest, Ben here has made $237,000. Now let's go over to $237,000. Arthur makes that at age 49. But Ben has made $373,000, even though he has not put in any more money. Now at $373,000, Arthur earns that about at age 52. But at that time, Ben here has already earned $524,000. Going again, looking at this scenario, Arthur reaches $540,000 at age 56. But by that time, Ben has made $825,000. So now going back down, Arthur makes about $850,000 at age 60. But at that time, Ben has made $1.2 million. And then at $1.2 million, Arthur makes that at age 63. But at that time, Ben has $1.8 million. And so at the age of 65, when Arthur makes about 1.5 million, Ben has 2.2 million. So what this chart pretty much tells you is that the power of compound interest plays a huge factor, but even more importantly, it is vital that you start to invest early, because even though Arthur only waited 8 years before he starts investing and he puts in $2,000 for every year all the way up to 65, his account balance never catches up to Ben, because Ben has the power of time and compound working in his favor. So let me quickly show you how this actually works using math. So now I'm going to go in and show you that the power of your return plays a huge factor. And this is all because of compound interest. So let me quickly play this video for you.
Would you rather work hard for money or have money work hard for you?
Right? So basically, as a person, we only have certain hours in the day to make money. But if you know the power of compound returns, you could actually make your money work for you instead of you working for your money. And this is how the rich get richer, right? Because they know mathematically you can allow your money to grow exponentially through this compound return.
Compound interest empowers you with that choice. Compound interest is a core financial principle that can drastically increase your wealth over time. But before we explore compound interest, it's helpful to understand simple interest. Simple interest is the interest you earn on just your principal. Let's say you invest $1,000 and earn 5% simple interest for 5 years. In year 1, you'll earn $50, which is 5% of your $1,000 principal. In year 2, you'll earn another $50, and each year thereafter, you'll continue earning.
So basically, simple interest is nothing more than a math formula, right? You guys probably seen this, remember this in your math class, right? Y is equal to mx plus b, right? And b is basically your y-intercept, or the amount of money, your initial investment at time 0. That's your y-intercept. M is your interest rate, and then X is your time. So in this example, let me pull up a graph and you'll see that, here, hold on one second. Let me pull up this graph here. You can see that, here we go. I can actually create a chart that will, hold on one second. Let me pull up this one. Here we go. So if I go to Desmos, you'll pull up what's called a graphing calculator. And we can actually plot this simple interest formula and see how our money grows. So if I just create a table here, and let's say you start off at age 18, right? And at age 18, the amount of money you have in your bank is $10,000. And then every year, 19, 20, you're making 10% return. So 10% you'll have is 11,000. Then you'll have 12,000, etc., right? And then you have 13,000. And here, this is how you can scale your graph so that you can actually see the points here. So I just click on the wrench and we'll make the x-axis, which is your age, go from 0 to, let's say, 65. And then we'll make our y-axis go from 0 to, let's make this 500,000. All right, so here, actually, let's just do 200,000. And here you can see, here, let's make this reverse contrast. And then if you want to connect the lines, you could just click on this, choose the color, and then choose lines, and you'll see the lines being connected. So if we continue this linear function, actually, this is starting at 18. Let's do 0 so that you see that the y-intercept is 10,000. And so we'll go at year 1, year 2, year 3. We'll go year 4, year 5. So here you'll see that your y-intercept is at 10,000, right? And then you're earning $1,000 of interest every year. And this is simple interest. That's why this is a linear equation and this is a straight line. So if I go 15,000, 16,000, whoops, 1, 2, 3, 4, 5, 11,000, 12, 13, 14, 15, 16, 1, 2, 3, 7, you're gonna have 17,000. 8 is 19,000. 9 is 20,000. Oops, 18,000. And then this is 19,000. And then by year 10, you'll have 20,000. And if you just go forward at year 20, you'll have 40,000. Oh, hold on. Wait, hold on. 21,000. $40,000. I'm sorry. Well, hold on here.